Hello, we are from Boğaziçi University. Goshgar is PhD student and I am master student in computer engineering. First of all, we would like to thank our professor Ağustos'un for his suggestions on the project and to the organizers of the conference for giving us the opportunity to present our work. Our paper is Multi-Criteria Evaluation of Publication Impacts, Deep Learning in Autonomous Vehicles. Usage of deep learning to solve real-world problems has been increasing in recent years, and autonomous driving is an example of that, where its integration with deep learning has potential to improve safety and operability issues. So we think that our findings will accelerate the technological advancements in education. Multi-criteria evaluation of publication impacts has been rarely studied in the literature, and Pareto-Vickers method proposed by Bigdole et al. Relatively assess the publication impacts, and we build on that method in our work. The main contributions of our paper are proposing a multi-criteria evaluation framework based on Pareto domination strategy to assess the impacts of the publication and authors, construction of two separate datasets, consideration of criteria for these datasets, and justification of conflicts among the criteria, and finally the identification of top 30 most impactful publications and authors. While searching the digital libraries, we use the query that is shown here. After that, we scanned manually the collected publications reference sections. We included workshop proceedings, conference proceedings, journals, surveys, and preprinted articles in our datasets. We have covered these four digital databases that are shown here. In total, we have 731 publications and 1,242 authors in our datasets. You can see the distribution of the publications over the time in this figure. The multi-objective optimization involves with the minimization or the maximization of multiple conflicting objectives at the same time under various constraints. In Pareto domination, the solution X dominates the solution Y if the solution X is at least equal to the solution Y for all objectives, and the solution X is strictly better than the solution Y for at least one objective. Here, Fi and Fj denotes the value for ith and jth objective functions for solution X and Y. Pareto domination is not always sufficient alone to provide complete ordering among all solutions. For this issue, fast non-dominated sorting mechanism can be used, which classifies the solution into different ranks with respect to their non-domination levels. The solution X is preferred over the solution Y if and only if rank of the solution X is less than the rank of solution Y, or if their ranks are equal and crowding distance of the solution X is greater than the crowding distance of solution Y. The publication metadata includes name, publication year, number of citations, and authors of the publication. The author metadata contains name, identification number, affiliation, research interests, number of yearly and total citations, number of total H index, and also I-10 indexes. The oldest publication is from 2006 and the most cited publication has 8,255 citations, and you can find such analysis for the authors also in the paper. We use citations, duration, and centrality as the criteria. You can see the citation graphs for publication and author data sets in the figures. And for the centrality, we calculated between the centrality score for each vertex in the graphs using the formula that is shown here. Other criteria are as the following: H index representing the number of publication of an author with at least 8 citations for each. I-10 index showing number of publications of an author with at least 10 citations. And lastly, average author citation, H index, and I-10 index calculated for publications. These are the correlation values among criteria for publication and author impacts that we've calculated. In the first table, we see that average author citation, average author H index, and average author I-10 index are highly correlated, and they are shown with red boxes. High significance value between duration and centrality, average author H index and centrality, and average I10 index and centrality shown in purple don't provide strong evidence for their correlations. And citation and duration of the publications is positively correlated, but citation needs to be maximized while duration needs to be minimized, so they are in conflict. And in the second table, we see that citation, H index, and I10 index are correlated to each other. For author impacts, they are again shown in red boxes. Pareto fronts for publication impacts are shown in this figure. X-axis represents the citation objective, Y-axis shows duration objective, and we have centrality objective in Z-axis. Optimal publications are marked as red in the red surface, and other publications are marked as black. There are 11 optimal publications in this figure. You can see the 30 most impactful publications in this table, with corresponding rank, crowding distance, citation number, duration, and centrality. The first paper is end-to-end learning for self-driving cars. Although the first paper got less citations than the second one, since it was published earlier, the first and the second paper cannot dominate each other. That's why they both are Pareto optimal and ranked as 0. The same reasoning can be applied for other publications, and you can find the references of the papers in our paper. Here you can see Pareto front for author dataset. Same as publications, x-axis shows citation objective, y-axis is for duration objective, and z-axis represents centrality objective. Here also the optimal publications are marked as red and others are marked as black. We have 16 optimal publications in the top ranks. You can see here the 30 most impactful authors with corresponding affiliation, country, rank, crowding distance, citation, duration, and centrality. The first author is Alex Kendall from University of Cambridge. In author's case, also like in publications, we have the same non-dominance concern. To conclude, we proposed a multi-criteria evaluation framework to assess the publication and author impacts in the domain of deep learning in autonomous vehicles. We use different criteria in citation graphs and justify the conflicts between criteria using Pearson's correlation. We constructed 2 data sets, one for publication and one for authors, and presented the Pareto fronts of these data sets. We then identified the top 30 most impactful publications and authors. We left constructing a web-based dynamic multi-criteria evaluation framework as a future work. Thank you for listening.